Well, dear students, in this video, I want to discuss with you about nuclear reactor. Nuclear reactor is a device where we use nuclear fission reaction for some constructive purpose. We use it to produce energy, convert nuclear fission, the energy, nuclear energy into electrical energy. We can produce new radioisotopes which are used for medical purpose, like in diagnosis. Radiologists use some radioisotope to diagnose some diseases like tumor in the body. And further, we produce new elements also using nuclear reactor. So here is the rough sketch of nuclear reactor. I will discuss the parts of nuclear reactors here. Uranium rods. Uranium rod used as fuels, and these are moderator rod of moderator, or some other material like water may be used here as moderator. Control rod, cadmium rod होती हैं ये, CD cadmium rod used as controller. They absorb the fast moving neutron to maintain a control chain reaction. Control rods are used to produce control chain reaction. Here, coolant CO2 is sent into this. It is a pump which sends CO2 gas. CO2 gas absorbs heat radiation more easily, become hot, and hot CO2 which absorb energy from the fragments of nuclear fission reaction. When uranium get fission, it releases energy in the form of kind energy of fragments, and that kind energy of fragments, when collide with CO2 molecules, produce heat which is absorbed, and hot CO2 is passed through this chamber, where it heats up cold water. Cold water converts into steam. Now you might be thinking, what is the purpose of steam here? Actually, you have learnt generation of electricity in electromagnetic induction generator. In generator, we have to use the coil or magnet, and the rotation of coil or magnet is opposed due to Lenz law, because the dies of induced EMF. It says that it opposes the cause by virtue of which it is produced, and that is a direct consequence of law of energy, because energy cannot produce itself. We need to do some work, and on the cost of that energy or work done, we obtain other form of energy. So steam is used to run the engine, steam engine which rotates the turbine or generator. Like railway engine was initially heat engine, steam engine. So steam is passed through the engine and rotate, our engine works, that rotates our generator. So this is the rough sketch of a reactor. Here inside this chamber, these are safety valves, because some radioactive radiations are produced. Those radiations are harmful for the body. They are absorbed by these thick walls of concrete, and no radioactive radiation come out of the nuclear reactor. Because of these thick walls, no radioactive radiation can come out. I've seen a nuclear reactor in Rajasthan, Kota. There is one town where it was there there was no noise, there was no cloud, there was nothing. Actually, nuclear energy, if used to convert into electricity, then it is very eco-friendly and clean source of energy. But we are afraid of this nuclear bomb. We are not using the home bomb, we are using their controlled chain reaction. Actually, I told you that 1 gram of uranium can produce the heat energy equivalent to 10 tons of TNT. So, where we use thermal power plants and we are burning coal, there mountains of ash of coal are there. We need large area. Nearly 20 kilometers square area is required for running a thermal power plant which is using coal as source of heat to produce steam. To run the generator, we need engine. Either we use petrol or we use coal or we use hydrostatic power, like the dams, hydro electricity producing dam. Their kind energy of water is used to run the generator. But to construct dam is also not easy. A large, very large area is required because to provide energy to the whole state or country, we have to produce large amount of energy. And a nuclear reactor, where we convert that into energy, electric energy, only need hardly 2 kilometers square area. And the residue left after nuclear fission reaction may have still some radioactive isotope, but a residue after 20 years of the use can be placed inside the earth of nearly area of room. So that way, nuclear reactor energy obtained from nuclear reactor in the form of electricity is very, very friendly with our ecosystem. Ecology will not be disturbed. So I hope you have got this point. So in books you will get different parts of the reactor: fuel, uranium rods are used as fuel, then moderator, graphite or heavy water used as moderator, coolant rod, coolant material is this. Heat produced is absorbed. The energy produced in the form of energy converted to heat, which is absorbed by coolant, and coolant energy is used to heat up water to produce steam. Then shield, used to avoid the emission of radioactive radiation, and safety devices, etc. Construction is this. Now application of reactor. Number 1, production of plutonium-239. Yes, production of plutonium-239. I told you natural occurring uranium has large mass of uranium-238, which is not fissionable material. Uranium-238 has large mass, much more large. I told you 0.7% is the uranium-235 of the natural occurring uranium. Majority is 238, which is not easily fissionable. This can be converted plutonium in nuclear reactor. A neutron strike converts this into 92 uranium-239. Uranium-239. I can write the reaction here. 92 uranium-238. 0 and 1. It produces 92 uranium-239. uranium 9239 decay into Neptune by emitting beta emission 93 NP 239 plus 10 plus antineutrino. Then 93 Neptune, 239. It is converted into plutonium 239 again by beta emission. (94 Pu) 239 electron plus antineutrino. So you see mass number has increased. So depletion of uranium 235 is also stopped. That way mass get increased. Such a nuclear reactor in which we use the reactor to convert uranium 230 into plutonium 239 is called breeder reactor. We can produce new element. So this is one use here. And then production of neutron beam, production of artificial radioisotope, and generation of energy, etc. Thermal reactor are those in which we convert energy into electricity. Breeder reactor is all that one which produce plutonium 239. So this is something about, you can read from the book, please. My knowledge may not be sufficient. So please consult the book for particular topic. This is important and interesting topic, and generally questions are asked. Now in the coming video I will be taking you to nuclear fusion reaction. Thank you. Please share the video, like the video. Like the video is important for me, not for you. It will encourage me that you are watching my videos. Ask your friend to watch the video, subscribe the channel, etc. Getting more subscriber increases my ambition to do more work. Actually, I am doing this thing for those students who are in the interior and not able to reach a teacher and save the time even. Please, but watch the video when you are alone. Sit alone in the room. Only then you can get it, because here also there is a lot of noise. You see, I can't avoid. In our country, people are not taking care of their neighbors. Unnecessarily, they do so many activities which are not required. Thank you.